Okay, we'll be starting the last section in chapter 1, 1.3. As I mentioned before, chapter 1 goes pretty quick. So we'll be going through most of 1.3 today, a little bit more to do tomorrow, and also review tomorrow. And we'll be testing in 2 days from today. Okay, and wrapping this up. All right, so 1.3 follows suit with the other ones. A lot of terms, definitions, and concepts. So a lot of this will be reading based and discussion based. Okay, and then filling in the guided notes. For those of you at home, too, these guided notes are set up perfectly when you're not here to read for understanding and fill in, and of course, listen to these discussions that we're having. Okay, all right. So there's these 4 learning targets in 1.3. That's it. But there's kind of a lot down here in this learning target. So discuss what it means to take a census. Describe simulations compared to observational studies and experiments, and then all these are all parts of experiments: control groups, placebo effects, completely randomized experiments, and then block experiments. All right, we should get through all 3 of those today. Okay. All right, so to begin, on page 22 in your textbook, I want you to start reading for understanding through 22. They're going to discuss in that blue box on page 22 the difference between a census and a sample. All right, and then once you get through 22 and 23, start reading in or filling in some of these definitions. Okay, give you a good 5 minutes to do those tasks. Okay, by no means do you have to memorize these 7 steps. This is just kind of the big picture, what we're going to be seeing throughout statistics this year. You know, we identify basically our goal in the beginning. Then we're going to, sample or set up some experiment, get some volunteers or sample. Then we do some stats with that data and we draw conclusions on the population. That's basically the cycle of statistics. Okay, what's your goal? How are you going to get your data? Crunch the numbers out of your data, draw conclusions about the rest of the population. Okay. All right. So a census, you probably already filled this in. This is data on the entire population. Okay. So that it's just a phrase for that data. So if I sample some kids at school, I call it a sample. But if I grab data on everybody at school, it's called a census. Don't get that confused with the parameter. Parameter now is the data on that. So if I have the high school GPA, the GPA is the parameter, but the census is the fact that I have the entire group. You guys have probably heard of the U.S. Census Bureau, right? Okay, that's why it's called the United States Census Bureau. They're trying to collect data on the entire nation, which is very tough to do. Even the U.S. Census Bureau and all the money they have to spend on that has a hard time collecting data on the entire population. Okay, but we won't go too far into that. The U.S. Census Bureau problems. Anyway, so let's go ahead and move on here with experiments and observation. I didn't mean they have problems. I just mean problems in collecting the entire population. Okay, so let's go ahead and take a look at these 2 definitions and compare these 2 concepts. All right, read those on page 23 and fill them in. Go ahead. All right, so observational studies are just that. You're just observing, taking data. So I could stand over by that window over there and observe how many people come to a complete stop at the stop sign, and I'm not doing anything to influence them because they can't see me. I'm just watching. Okay, so there's an example of observational study. Experiment, though, is different. You're going to create some type of change. All right, so if I take that same example, I collect the data of people stopping there, and then I take the stop sign and make it 10 times larger and compare the difference. I just, tried to create a treatment to see if I could find a possible change in the variable being measured. And the variable would be whether or not they're stopping more or not. Okay, so there's the main difference. Is there a treatment being imposed? Okay, all kinds of examples of experiments we could go through. I gave you one. There's experiments being conducted right now, right, with the COVID vaccine and treatments, and they create what's called control groups. We'll get to that in a moment, but let's take a look at this example right now in the textbook. Let's read through example 4, A and B. Go ahead, I'll pause to let you do that. Okay, this experiment brings up a term we're going to see here as well, so I want to talk about this. Confounding variables, or sometimes called a lurking variable. All right, now right away they said this sword plant was going down, right? Fewer and fewer plants. Okay. Can we automatically blame that on the goats? No, maybe there's some other lurking variables. What about the weather conditions? Maybe there's another insect that's going around and making these things die. Who knows? We could blame a lot of other lurking variables for it unless we actually try to control it, where we can only blame the goats now. So that's why they created two different plots, right? So these two different plots are next to each other. Now they're experiencing the same insects, the same weather, all right? And now they can just attribute the difference to the goats, all right? Because we have plants in each one, in each of these plots, but one of them, they didn't let the goats go in. The other one, they did. So they controlled that one variable. Now they can account for just the variable they're looking for, okay? Not the weather, not the insects or anything else, okay? Make sense? So that's the experiment. Okay, so let's read the bottom of 23 through 24 and fill in these key terms while you're doing that. All right, the placebo effect is an amazing phenomenon that experimenters have to keep in mind. You guys have all experienced it, whether you know it or not. You've been subject to the placebo effects because our brains are remarkable things that react just with fake treatment or any treatment at all. Let's take a look at this example here. Want to help balding men keep their hair? Give them a placebo. One study found that 42% of balding men maintained or increased the amount of hair, so maintained or increased, on their heads when they took a placebo, just like some type of cream. Okay, so 42% effectiveness with a placebo. It was fake cream. The other people that actually had the cream showed 86% of the men either maintained or grew no hair. So that's something you got to think about when getting a medicine and doing these treatments. So for example, these people that actually got the treatment, all right, had a success rate of 86%. Well, we can't attribute all of that success just to the cream. Why? Because the placebo effects accounted for, what was it, 42%? 42% of that. So really, we should subtract that difference, and we get a difference of 44%. That's what the real medicine did. So the placebo effect is so powerful that you always got to have what's called a control group or placebo group to realize, because if I didn't have that group, we might say that the whole thing was just from the placebo, right? I mean, the whole treatment might have just been from the power of the mind, okay? But then when you add the placebo group, we could say, okay, well, at least there's a difference. So that means that the treatment actually did have an effect, okay? Something researchers always have to take into account, the placebo effects. Got another interesting video on that too I want to show you guys at home. I'll put the link on the website. Okay, so these are filled in by now. Let's take a look at this example 5. If you haven't read this yet, go ahead and pause to do that. All right, so here's kind of a completely randomized experiment. Basically just means you need to create random groups. All right, so you want to randomize them into a group of, so I'll put group 1 here, 149 patients, and then, we should divide it into 2 equally sized groups is the goal here. And we know how to do SRSs now through assign them numbers, put them in a hat, whatever. We can use the table in the back. Our calculators can do random numbers, so we find some way to randomly assign them. Okay, so in the group 1, you can flip a coin for which group gets the treatment and which one doesn't. The laser holes in the heart, and then the other group had no holes in the heart. Why? Because they're accounting for the placebo effects to see if they saw the success just because of having the surgery. And that could be the case. All right, so this is just kind of the basic design of most random experiments with some type of control group or placebo group, okay? And then what you do at the very end, you compare the pain relief. That's what's the variable you're looking for. Compare it at the end. All right. Okay, a block. This is a group of individuals sharing some common features that might affect the treatment, or I think a better word is the response. Okay, sorry, not a lot of room there, but just try to squeeze it in. So a group of individuals sharing common features that might affect the response. So if I were to use that same example about the heart treatment, maybe we know ahead of time that males and females might respond differently to the treatment, the pain relief. So if we think you've got a different response in the groups ahead of time, we block it to begin with. Okay, so a randomized block experiment is going to do this. Here's a good visual aid on it. Everything else is the same. You just block it to begin with. And sometimes the numbers might not be even. So out of those 300 volunteers, maybe I have 160 men, 140 women. That's fine. You block it. Now you go through the same process. You randomly assign half the men to group 1, group 2. Same thing with women. Okay, all of this is a repeat of what we did in the other page. Okay, so simple. If we say block design, you block it if you think they might respond differently to the treatment. Okay, so go ahead and write down that definition 2. It's on the bottom of page 24. All right, let's just wrap it up with this discussion here. We kind of already got ahead of this with control groups. Remember, you want a control group to account for some of these lurking variables. We talked about it with the goat example. We don't want to blame it on the weather. If or other bugs or something else going on, or fertilizer. If you create a control group and you keep everything relatively the same, then we can account for these lurking or confounding variables. It eliminates those. Okay. So that's why every good experiment has some type of control group. Quite often it means a placebo group. Okay. All right. You always want to randomize your groups so you create equal groups. If I'm doing a study of classrooms in here and I want to measure something, I don't want to just compare this classroom to the one next door because those kids might be different. Okay. So you got to create equal groups to also get rid of other blaming variables. Okay. And replication of the experiment just means a lot of patience. Doesn't mean do the experiment over and over again. Experiments are hard to conduct. Just make sure you have a decent sample size. You don't want to do that hard experiment with just 2 people, right? Or 3 people. Then you could say, well, they already had a low tolerance for pain or whatever. Replication means, make sure you have a decent sample size. It's just many patients, right? Big sample size when possible. Okay, we got through, I'd say about 3/4 of it today. First 3 learning targets. So we'll just wrap it up tomorrow with the rest of this section of notes and also chapter 1 review. Okay. One last thing was double-blind experiments. Double-blind means neither the individuals in the study, which is usually always the case. They don't know if they have a placebo or not, but also the observers. They don't know who has the treatment, just to eliminate any biases they might have when recording the data, which you'd think you wouldn't have that type of bias, but maybe if a doctor really wants to see something be successful, they may, have bias towards recording the observations. So double blind helps control for those biases. All right.